You look at an empty room, it seems simple enough. Four walls, a floor, a ceiling. Nothing in between. You call it empty, or you take a glass jar, screw the lid on tight, and say it's empty. But is it? Well, no, not really. The room is full of air. The jar is full of air. We know this. It's mostly nitrogen, about 20% oxygen, a little argon, some carbon dioxide, and traces of other gases. It's also full of dust motes dancing in sunbeams. It has microscopic bits of skin you've shed. It has tiny organisms floating around. It's a busy place, that empty room, so you think, okay, let's get rid of the air. You hook the jar up to a powerful vacuum pump. The pump whirs and sucks all the air out molecule by molecule. It pulls out the nitrogen, the oxygen, the dust, everything. Now the jar is sealed tight. Inside is a vacuum. Is it empty now? It's emptier, for sure. Way emptier than any room. But it's still not truly empty. The walls of the jar are at a certain temperature. That means they're radiating heat. Heat is just infrared light, a form of electromagnetic radiation. The inside of the jar is filled with these photons of light, bouncing around, so it's full of energy. Alright, you say, let's cool the jar down. We'll take it to a lab and cool it to absolute zero, or as close as we can get. At absolute zero, all atomic motion is supposed to stop. No more heat, no more radiating photons. We'll also build the jar out of perfect lead shielding to stop any outside radiation from getting in. We have our vacuum pump, our cooling system, our radiation shield. Now, inside that jar, is it finally, truly, absolutely empty? The answer is still no. And this is where things get strange. This is where our everyday understanding of nothing completely falls apart. To understand why, we have to stop thinking about a room or a jar and start thinking bigger. Let's go to the best vacuum we know. Let's go to outer space. Deep space, far between the galaxies. That's the ultimate empty, right? The great void. For a long time, that's what we thought. A perfect, cold, dark nothingness. But space isn't empty either. Not even close. If you took a box the size of a refrigerator and put it in the deepest part of intergalactic space, you would still find a few hydrogen atoms in it. Just a handful, maybe. But not zero. The universe is filled with a very thin, spread-out soup of particles called the interstellar medium. Or it's mostly hydrogen and helium left over from the Big Bang. It's not much, but it's not nothing. And there's more. That same box is constantly being pierced by things. High-energy particles called cosmic rays, blasted out from exploding stars halfway across the universe, are zipping through it at nearly the speed of light. They would pass right through your box, and without you ever noticing. There are also neutrinos. Trillions of them. Neutrinos are tiny, almost massless particles that barely interact with anything. They are sometimes called ghost particles. There are trillions of them passing through your body, through this planet, right now, every second. They come from the sun, from other stars, from the Big Bang itself. They fill all of space. So, your empty box in the void is swarming with a storm of invisible ghost particles. And then there's light. Even in the darkest part of space, far from any star, your box is filled with light. It's not visible light. It's microwaves. It's called the cosmic microwave background radiation, or the CMB. It's everywhere in the universe, in every direction, all the time. It's the leftover heat from the Big Bang. Think of it as the afterglow of creation. When the universe was very young, it was incredibly hot and dense, glowing white hot. As the universe expanded, that light stretched out into longer and longer wavelengths, until it became the faint, cold microwaves we detect today. If your eyes could see microwaves, the entire night sky would glow with a soft, uniform light. This radiation gives empty space a temperature. It's not much, about 2.7 degrees above absolute zero. But it's not zero. Space has a background warmth. It's filled with ancient photons. So, even deep space is not empty. It's a thin soup of atoms, a shooting gallery of cosmic rays, a blizzard of neutrinos, and it's filled with the afterglow of the Big Bang. But let's pretend we could get rid of all that. Let's imagine we could create a perfect box. We magically wave a wand and remove every atom, every cosmic ray, every neutrino, every single photon of light. We shield it from everything. Inside this magical box is a perfect absolute vacuum. No particles, no radiation, no matter, no light, nothing. Is it empty now? I know you see where this is going. The answer, astoundingly, is still no. The reason has to do with the fundamental nature of reality itself. In our everyday world, things are stable. A book on a table stays a book on a table. But when you get down to the smallest possible scales, the quantum level, reality is not stable. It's a fuzzy, uncertain, chaotic place. There's a rule in quantum mechanics called the Heisenberg uncertainty principle. Most people have heard of it. It's usually described as a limit on what we can know. For example, you can't know a particle's exact position and its exact momentum at the same time. The more precisely you measure one, the less you know about the other. But the principle is deeper than that. Well, it's not about our measurement limitations, it's a fundamental property of the universe. Things at the quantum level just don't have a precise position and momentum at the same time. Their properties are inherently fuzzy. This uncertainty also applies to energy and time. You cannot know the exact amount of energy in a system over a very short period of time. This has a bizarre consequence. For a very, very tiny fraction of a second, the amount of energy in a specific point in space can fluctuate wildly. It can borrow a little bit of energy from the future as long as it pays it back almost instantly. What does this have to do with empty space? Well, Einstein taught us that energy and mass are two sides of the same coin. His famous equation, E equals mc2, says that you can convert energy into mass and mass into energy. So, if the energy in a point of empty space can fluctuate, if it can briefly spike upwards, then for that tiny instant, that blip of energy can create mass. It can create particles. This is what happens in our perfect empty box. All the time, everywhere. Out of nothing, a pair of particles will spontaneously pop into existence. It's usually a matter particle and its corresponding antimatter twin, like an electron and a positron. They exist for a fraction of a second, borrowing their existence from the uncertainty of the vacuum. Then, just as quickly, they find each other and annihilate, vanishing back into the nothingness they came from. The energy loan is paid back. This isn't a wild theory, it's a core prediction of our best model of physics, quantum field theory. It's happening constantly in every cubic centimeter of space around you and in the farthest reaches of the void. The vacuum, the nothing, is actually a seething, bubbling, chaotic foam of these so-called virtual particles popping in and out of existence on timescales too fast for us to see directly. Empty space isn't empty and quiet. It's a roaring, frenzied ocean of potential. You might be thinking this sounds like science fiction, or a nice mathematical idea, but is it real? How could we ever prove that this particle foam exists? We have. There's something called the Casimir effect. It's one of the most brilliant experiments ever devised. The idea was proposed by the Dutch physicist Hendrik Casimir in 1948. He thought, if this quantum foam of virtual particles is real, it must exert some kind of pressure. Here's how you test it. You take two metal plates, you make them perfectly smooth and uncharged. You place them in a perfect vacuum, and you bring them incredibly close together, just a few nanometers apart. Now, think about the virtual particles. They are popping into existence everywhere, all around the plates and in the tiny gap between the plates. These particles have wavelengths like ripples on a pond. Outside the plates, virtual particles of all possible wavelengths can exist. Big ripples, small ripples, everything. But inside the tiny gap between the plates, only certain wavelengths can fit. Here, a ripple that is bigger than the gap can't form in there. This means there are more types of virtual particles, more quantum foam activity happening on the outside of the plates than on the inside. All those particles popping into existence on the outside are pushing on the plates. The fewer particles popping into existence on the inside are pushing back, but not as hard. The result is a net force. The greater pressure from the outside pushes the two plates together. And when physicists did this experiment, that's exactly what they found. A tiny but measurable force pushing the plates together. A force created by nothing. A force generated from the energy of the empty vacuum itself. The Casimir effect is real, the quantum foam is real, empty space has a real physical energy. So our perfect box is not empty, it's filled with a simmering soup of virtual particles, a hidden energy that reveals itself when you look closely enough. But we are not done. The story of empty space gets even stranger. So far, we've talked about what's in space. Atoms, light, virtual particles. But we haven't talked about what space is. For most of history, we thought of space as a stage. A big, dark, empty box where things happen. It was just a background. The universe was the actors, the stars, the planets, and space was the passive, unchanging stage they moved upon. Einstein changed all that. With his theory of general relativity, he showed that space is not a passive background. Space is a thing. It's a dynamic physical fabric. He called it space-time. He said that massive objects don't just move through space, they warp and bend space itself. Think of it like a bowling ball on a trampoline. The bowling ball creates a dip in the fabric of the trampoline. A smaller marble rolling nearby will be drawn into that dip. That, Einstein said, is gravity. It's not a mysterious force pulling things together, it's just objects following the curves in space-time created by mass and energy. The Earth isn't being pulled by the sun. The Earth is following a straight line through the curved space-time created by the sun's immense mass. This means that a gravitational field is a property of space itself. The field is always there. Even in our perfect box, far from any star or planet, the fabric of space-time exists. It might be very flat, but it's not nothing. It's the medium that would tell any particle how to move if one were to appear. Space isn't an empty container. It's a fundamental part of the contents. This idea of fields is critical. Physicists now believe that everything is a field. There is an electromagnetic field that fills all of space. A photon, a particle of light, is just a little vibration, a ripple in this field. There is an electron field that fills all of space. An electron is just a little knot, a localized excitation in the electron field. Every particle we know of is just a ripple in its own corresponding field that permeates the entire universe. So, our perfect empty box with no particles in it is still full. It's full of all these fundamental fields lying dormant. They are the substance of reality, just waiting for a little bit of energy to make them vibrate and create the particles we call matter. The vacuum isn't the absence of things. The vacuum is the ground state, the lowest energy state of all these fields. It's the quiet, undisturbed version of everything. And now for the final, biggest twist. It turns out that this empty space, this ground state of all the fields, makes up most of the universe. In the late 1990s, astronomers were trying to measure how quickly the expansion of the universe was slowing down. They assumed it must be slowing. After the Big Bang, everything flew apart. Gravity from all the galaxies should be pulling everything back together, acting like a brake on the expansion. They pointed their telescopes at distant exploding stars called supernovae to measure the expansion rate. And they found something that made no sense. The expansion wasn't slowing down, it was speeding up. The universe is expanding faster and faster every day. This was a complete shock. It was like throwing a ball into the air and watching it accelerate up into the sky instead of falling back down. Something was pushing everything apart. Some kind of anti-gravity force was built into the fabric of space itself. Scientists don't know what this is, so they gave it a mysterious name, dark energy. And the best idea we have for what dark energy is that it's the cost of having space. It's the intrinsic energy of the vacuum itself. Remember that quantum foam, the energy of all those virtual particles. The Casimir effect proved it was real. Well, maybe that vacuum energy, spread out over the entire cosmos, is what's driving the universe apart. It seems that empty space has a kind of springiness to it, an inherent pressure that wants to expand. The problem is, when physicists try to calculate how much energy the quantum foam should have based on our theories, they get a ridiculously huge number. A number so big it would have blown the universe apart in the first fraction of a second. The amount of dark energy we actually observe is tiny in comparison, though it's still powerful enough to accelerate the entire universe. Nobody knows why there's such a big disagreement between the theory and the observation. It's one of the biggest mysteries in all of science. But here's the most important part. When we add up all the stuff in the universe, all the stars, galaxies, gas, and dust, we can see it only accounts for about 5% of everything. About 27% of the universe is something called dark matter. This is some kind of invisible particle that doesn't interact with light, but it has gravity. We know it's there because we can see its gravitational effects. It's the invisible scaffolding that holds galaxies and clusters of galaxies together. Without it, they would fly apart. Dark matter fills the empty space within and between galaxies. It's a huge component of reality that we can't see or touch. And the rest, the remaining 68%. That's dark energy. The vast majority of the energy and mass in our universe is the energy of empty space itself. The nothing is actually the biggest something there is. So let's go back to our starting question. Is empty space truly empty? The answer is a profound and definitive no. An empty room is full of air. A vacuum in a jar is full of heat radiation. The void of outer space is full of stray atoms, cosmic rays, neutrinos, and the light from the Big Bang. And even if you could remove all of that, you'd be left with something even more fundamental. You would be left with the fields that make up reality. You'd be left with the fabric of space-time, which can bend and warp. You would be left with a quantum foam, a seething ocean of virtual particles popping in and out of existence, a process so real it can push physical objects together. And you'd be left with the mysterious dark energy, an intrinsic property of the vacuum that is pushing the entire universe apart and makes up the majority of everything that exists. The idea of nothing is a human invention. We see a space between objects and we call it empty. But the universe doesn't work that way. The space between things is not a void. It's a dynamic, complex, and powerful entity. It's the stage, the actor, and the script all at once. The vacuum isn't the absence of reality. The vacuum is the foundation of reality. Everything we see, every star, every planet, every person is just a little ripple, a temporary excitation on top of this incredibly rich and active emptiness. The truth is, we live inside an ocean. We just happen to call the water nothing. We are so used to the substance of space that we don't even see it. It's the most common thing in the universe and also the most mysterious. So the next time you look at a patch of dark night sky between the stars, don't think of it as empty. Think of it as the engine of the cosmos. It's the busiest place there is.